Hello everyone, my name is Ren Chao, a PhD student of INSA Huang Normandy. This presentation is for Uncertain 2020. The paper is written by me, my prof Eunice, Didier, and Souza. And it's an honor for me to present our study. And today my presentation is about the global sensitivity analysis of offshore wind turbine jacket. I will mainly talk about our study in 4 parts. One is background, the methodology, and the result of sensitivity analysis. And finally, will be concluding remarks. Now let's start with background. Why we do the sensitivity analysis of offshore wind jacket? First, because offshore wind turbine is one of the most promising renewable energy, and the offshore wind turbine foundation has caused a high part of construction and installation. Since in recent decades, offshore wind turbine have been installed in deep water. In addition, optimization of offshore wind turbine foundation is complex due to multiphysics simulation, including aerodynamic, hydrodynamic, fluid, and structure interaction. There are many uncertain parameters in optimization process, and the sensitivity analysis can qualify the effect of uncertain parameters, and then based on the result of sensitivity analysis, we can reduce the parameter of demotions. That's why we do the sensitivity analysis of offshore wind turbine foundation. And some sensitivity analysis of offshore wind turbine foundation can be found in literature, but there are always some limits. For example, sea current is not considered, and the wind and wave are assumed to be co-direction, and focus only on one specific element of foundation. They provided limited information. Thus, in our study, we will consider these parameters. Then I will talk about the methodology used in this study. First, it concerns the offshore wind turbine model, and then the sensitivity method used in this study. Let's come into the offshore wind turbine model. The wind turbine model used in this study is fixed bottom offshore wind turbine with jacket foundation designed for OCGAT project. It's very classic offshore wind turbine. I'll focus on the jacket foundation as shown in the right figure. In this study, the uncertain parameters considered are molecule, geometry, and the environmental parameters. Their influence on the maximum stress and displacement will be discussed. Then it's about log simulation. The aerodynamic and the hydrodynamic simulation are mainly based on two software. Aerodynamic forces simulated in one wind turbine software fast, and hydrodynamic load like a wave and current are designed in finite element software ANSYS. The two sensibility analysis method has been used. One is Murray's green method, another is Fourier amplitude sensitivity test. The whole process is in the right figure. The aerodynamic forces and the moment are taken from fast simulation. And then we define the bound for the uncertain parameters, random symboling for each sensibility method, and the ANSYS will carry out the simulation and return the maximum stress and displacement in the different part of the jacket. Finally, we can get the sensitivity index of the two methods and compare with each other. Here, I list all the uncertain parameters and their bound as shown in the right tables. The molecule, geometry, wave, sea current, and wind load, and all the parameters are assumed to be independent and follow the uniform distribution. For the response, the maximum stress and displacement in the different zone and paths of jacket are considered. The zone and path of the jacket classified in the right figure. Then I will briefly talk about the method of global sensitivity analysis used in this study. First is the Murray-Green method, also called elementary effect method. It bases on the one factor one time. It randomly evaluates the elementary effect of each factor. Then after enough repetition, the mean value mu and the standard deviation sigma of elementary effect of each factor can be evaluated. With the mean value and the standard deviation of each factor, we can classify the factors into three groups. One, the factor have little effect. Two, the factor have important overall effect without interaction. Three is the factor have large linear and interaction effect. In this study, the mean value and the standard deviation are normalized in the right equations. Second method is about the Fourier amplitude sensitivity test. As shown in the right figure, each input factor is transformed and associated with one special frequency, omega. The transformed factors are the new input for the method. After the method evaluation, the variance of the output can be calculated. The portion of output variance arisen by each factor can be evaluated. In addition, the portion of the output variance arisen from all but not one factor can also be evaluated. Finally, the Fourier amplitude sensitivity test index S and S total can be calculated in the right equations. And next, I will present you the result of the two sensitivity method. First is about the result in the Morris-Green method. As we can see, considering the maximum stress for the zone below the mean sea level, like a mud and the K2S zone, the wave parameters have a high overall influence and interaction. For example, in the mud zone, the wave parameters like the wave behavior and wave height and wave directions have higher interaction and overall influence. And for the zone above the mean sea level, like K1S zone and the Y-up zone, the geometry parameters like diameter, thickness, and the wind load has more influence. It's clear in the Y-up zones. And for the Fourier amplitude sensitivity test, considering maximum stress, the same result can be observed. In the zone below the mean sea level, the wave parameters have more influence, and in the zone above the mean sea level, the geometry parameters and the wind load has more influence. And it should be noticed that a little differences can be observed in these two methods. In the Morris-Green method, in the mud zone, wave directions have the interaction with other factors, while in Fourier amplitude sensitivity test, it's not that clear. And in K1S zone, the wave parameters seem to have interaction with other factors in Morris-Green method, but not in Fourier amplitude sensitivity test. But all in all, the result of two methods are mostly in good agreement. And to compare the result of two methods, here are the results of two methods in ES and NU part. As we can see, they show the two methods have the same result, considering maximum stress in the ES part, which is below the mean sea level. The wave parameters have big influence in both two methods. And considering maximum displacement in the NU part, we can also the two methods have the same result. Finally, will be the concluding remarks. In conclusion, the maximum stress of different parts of the jacket is sensitive to the different parameters. The zone of jacket below mean sea level is more sensitive to the wave parameters. And the zone above the mean sea level is more sensitive to the geometry parameter and the wind loads. And then it should be noticed that the result of two sensitivity analyses are mostly in good agreement. And more importantly, if we consider the maximum stress and displacement, 23 parameters can be reduced to 10 through the sensitivity analysis, which will make the optimization process easier. And finally, I would like to thank the financial support of the China Scholarship Council and the support of the INSA Normandy. That's all. Thanks for your attention.